All right, so today is going to be our first day looking at word problems. Okay, so now the key thing that when you're doing a word problem, you always need to start by figuring out what exactly you're being asked for. Okay, so this sounds really stupid because you might be thinking to yourself, well, duh. Okay, but what I find a lot of times with students in this class is that it's just like, it's almost like a rush. And as you're rushing through, you kind of forget to think about like, what are you actually looking for? And then what part of the parabola is that going to, where is that feature going to be found? Okay, so if you're looking for the height of something, well, what does that mean? It should be a y coordinate, right? Y coordinates are heights. Okay, and if you're looking for like a horizontal distance, then that should be an x value, right? Okay, and then you're going to be thinking about, well, is it the highest point or the lowest point? Well, that should be a vertex. Okay, is it a point where something hits the ground? Well, that should be an x-intercept. Okay, so you got to be kind of asking yourself those questions. And then you're going to graph the equation on your calculator if necessary. It's not always necessary. And if it's not necessary, don't do it because it's just a waste of time. And then we're going to use it to answer some questions. Okay, so example, the arch of the Gateshead Millennial Bridge forms a parabola with this equation where x is the horizontal distance in meters from the arc's left end and y is the distance in meters from the base of the arc. Okay, so now this description right here of what x and y stand for, that's actually really important. So you need to stop and take a second and think about what that means. So what it's telling you is that your x values, that's the horizontal distance from the arc's left end. So if this is where 0 is, okay, and this is, I don't know, over here, some number, right? What it's saying is that this is the left end of the arc. So your arc is going this way, right? As these x values are getting bigger, the distance from the left side is getting bigger. Okay, and then the y value is the distance in meters from the base of the arc. So your y value is basically just your height. It's telling you how tall this thing is. Okay, and we want to know the width and the height of the arc. Okay, so what are we going to need to know? Well, to find the width of the arc, I'm going to need to know what the distance is from here to here. Now, because of the description, I know that it starts at 0, 0, that really just means I have to find this x-intercept, and that's going to give me the distance between them. If it didn't start at 0, I'd have to find both intercepts and then subtract them to find the distance between, okay? But in this case, we just go... Sorry, that was like an aborted sneeze. Whew. Sorry, really weird thing to happen when you're recording a video, but you know, this is life. Okay, so to find the width, all right, that's going to be our x-intercepts. All right, now later we're going to talk about how you find those without using a calculator, but for now you're just going to need a calculator. Okay, the second thing we need is the height of the arc. Okay, well, the height of the arc, figuring out how tall the thing is, that's going to be this point right here. So that is my vertex, and if I want the height, that means that to find the height of the arc, I need the y coordinate, right, of the vertex. All right, now I don't even need to graph this thing to figure that out. Take a look at this guy, right? I know the coordinates of the vertex. Well, my coordinates of my vertex, it's 53, remember it's backwards, and then exactly what it looks like, 45. So how tall is this thing? Well, it's 45 meters tall. Done. So there's half the question right there. Okay, so like I said, only go for the graph if you need it. Okay, I don't yet know, or we haven't looked at how to find the x-intercept just from this equation. So this is where we're gonna need our graph. So I'm gonna grab my calculator. Okay, I'm gonna go into y equals. I used these equations before, I gotta get rid of them. So I'm just gonna hit the clear button to zap that guy, come down here, hit the clear button to zap that guy. I'm going to come back up here and type in this equation. So remember, your negative key and your subtraction key are different. You want this guy, not this guy. If you get an error when you go to graph, that's probably what you did wrong. So 0.016 parentheses x minus 53, squared plus 45. No, you don't need to have that extra 0 in here, right? If I get rid of this 0, it's going to do the exact same thing. So that doesn't actually matter. All right, so here's my graph. Now setting my window, I'm thinking about this, right? We said the vertex is at 53.45 up here. Okay, and I'm looking for where it crosses the ground. So when I'm looking at my window, my X values, I don't know exactly where this is gonna be. All right, but if it's at 53 for the vertex, I know it's gonna be at least 100. So I'm gonna go for my X values, I'm gonna go a little bit less than 0, because I know it starts at 0, but I just wanna be able to see a little bit beyond it. So actually, let's go with -5. And let's go up to, say, 150. That should be wide enough. And then for my Y values, again, I don't want to start at 0. I know the bottom of the arc's at 0, but I'm going to go from -5 just so that I can kind of see both sides of the axis. And then for my Y max, I know the max height is 45, so I'm going to say 50. All right, and let's take a look at our graph. These guys are really, really thick and dark. That's just because I didn't change my scale, right? Remember how we said it's scaling at ones? So this thing is trying to put 1 tick mark between every number from -5 to 50. That's why it looks a little weird, but it honestly doesn't make a difference at all. I never really adjust that. Okay, so here's my graph. We already found the vertex. We can verify that that's the vertex if you want. Second, calculate maximum value in this case. Okay, and then I want to be on the left and the right. So I'm going over here to the left, hitting enter. Oops. Well, oops. I accidentally hit a button and now it's asking me for a number. This is just an alternate way of doing this here. Let me go back and show you. All right, so if I want my intersection, not my intersection. I'm sorry, I hit the wrong one. My maximum. Okay, I can either come over here and hit enter and give it my left bound, but the other option that you have is you can just type in the number. Okay, so since I'm just checking this one and I'm pretty sure it's at 53, I know that 60 is going to be somewhere on this side of that vertex, right? So I can just type the number 60 for my right bound and it'll jump me there. So it's also a nice use. And then I guess just somewhere in the middle. Okay, and look, there's my vertex. And again, like we talked about before, there's that calculator screen error. That is not really the number 52.99999. It's 53. We can tell, we know from the equation. It's just a calculator glitch that happens, okay, that you have to disregard. All right, so then we're gonna find our intersection over here. So I'm gonna do second, calculate, and I want my 0, not the intersection, I apologize, I said the wrong word. So I want my 0, and I want a left bound, a right bound, and a guess. Now, I know that 60 was here, right? So I'm gonna try to save myself some time. I don't wanna move that spider all the way over here. So I'm just gonna try, let's type in the number 80. Oh, look, that's definitely on the left side, okay? And then if I wanna find my right bound, you can either scroll over or you could guess another number. We've passed it, I'm off the screen, no big deal, it's over there somewhere. And then I'm just moving back over a little bit, there's my guess. So my 0 is at 106.03. Okay, so my x-intercept is at the point 106.030. And since based on the description that they gave me, I know the other edge is at 0, 0. What does that tell me? Well, it tells me that the width is 106.03 meters. Okay, so there's the 2 answers to my question. All right, so that's how you're going to kind of use these. Now let's take a look at this guy. So this one, we're going to look at this one a little bit differently. I'm going to show you a different way you can do it that will save you a little bit of time. So the path of Teddy's kick in football is modeled by this equation. How high did the ball go? How far did the ball go? So we've got this equation, okay? And basically what's happening is he is kicking his football. Ta-da! Okay, so that's what my graph looks like. We want to know how high did the ball go? Well, that's going to be my vertex. And then how far did the ball go? That's going to be my x-intercepts. Okay, so let's think about this one and see if we can do it without the calculator, because putting it in the calculator can take you a lot of extra time. So let's take a look at this. I know my vertex already, right? My vertex is the point 20, 15. So my vertex is 20, 15. Okay, so we got that. So I know that my height of the ball is going to be 15 feet. All right, so that's good. All right, now how far did the ball go? So this is going to be my x-intercepts. And actually, you know what? I can't do this without a calculator. Why can't I do it without a calculator? Because I don't necessarily know. The description of what x and y stand for is a little vague. I don't actually know if this goes through 0, 0. Okay, if I did know it went through 0, 0, then I could use the fact that I know these things are symmetrical, right? So here's what my guess is. And I'm going to verify this in just a second. But here's my guess. My guess is that on this little paper right here, that I've got one x-intercept here and one x-intercept here, and that my vertex is halfway between. Okay, the x-intercept of that, or the x-coordinate of the vertex is at 20, right? Well, if this point is truly at 0, 0, then the distance between these two dots has to be 20, right? Because that's how we measure x-coordinates. Which means the distance between these two would also have to be 20 because parabolas are symmetrical. And if that's the case, then that's going to have a coordinate of 40. So my guess is that the ball goes 40 feet. But again, I'm not 100% positive on this 0, 0 thing. So I'm going to go ahead and throw it in my calculator and check. All right, so y equals, clearing this out, negative 0.04, 4, parentheses, x minus 20 squared plus 15. All right, when I take a look at my graph, we kind of already sketched this out a little bit, what we think it's going to look like. So I'm going to make my window, I'm going to stick with that -5, but I only want my x max to go up to like, say, 50. Right, my y min, I'm going to stick with that -5, but I know my max height's 15, so let's go up to like 20. I always go a little bit beyond just so I can see the whole thing. Cool, there's my graph. All right, now, I'm guessing that this point 0, 0, right? So I could use my intersection feature, or let me just check it. I'm going to use my trace button. If I use my trace button and I type in 0 and hit enter, oh, 0, -1. So my x-intercept is not actually 0, 0. Rats. Okay, so now I'm going to have to calculate it. So let's calculate the 0. Here's my left bound, my right bound, and my guess. All right, so my first 0, my first x-intercept is at 0.64, 0. So it's pretty close. Honestly, this number is probably just a rounded number, and it was supposed to be 0, 0. But what can you do? All right, so other option, find our other 0. Way over. You see how annoying this is? Right? It takes forever for the stupid little spider to move across. That's why I sometimes just type in a number. All right, I'm on the left. I'm on the right, and somewhere in the middle. So this guy is at 39.360. Make sure I round it to 2 decimal places, so I round it to 2 decimal places, okay? So then if those are my two x-intercepts, then I just need to find out the distance between the two of them to figure out how far the ball went, right? So I'm going to do 39.36 minus 0.64, so 38.72. So the distance between those two is 38.72 feet. Okay, so that is how far it went. I guess I'm just going to write how far it went. It was kind of weird, but there we go. So I got our height and the distance traveled. All right, last guy. So here's my equation, -32x squared plus 39x. All right, comparing the time in seconds it takes a dolphin to jump y feet out of the water. We want to know how high did the dolphin go? That's going to be the vertex. Why is there no constant? And then how far does it take for the dolphin to land? All right, so let's take a look at this graph. Okay, so we notice this one's in standard form. Vertex, not so easy to pull out of standard form. So we could calculate it, which yeah, I'm gonna go ahead and calculate it, okay? So I'm gonna use, to find my vertex, the opposite of b over 2a. A, b, c would be 0, right? So the opposite of b would be -39 over 2 times a, -32. Okay, so -39 divided by, okay, and since I want both of these things in the denominator, I'm going to have to use parentheses around them. So I'm doing 2 times -32 in parentheses. Okay, if you don't use the parentheses, you're going to get the wrong answer. All right, so this works out to about 0.609. Now, I'm going to plug that back into this equation. And here's the part where you need to be careful. I am not going to type in 0.609. Okay, so here's what you're not going to do. You are not going to do -32 times 0.609 squared plus 39 times 0.609. okay? 0.609. This is the wrong thing. Why is this wrong? Because this number's rounded, right? If you take a rounded number and you use it to do further calculations, you're going to get a rounded answer. It's not going to be super, super accurate. Okay, so here's what we are going to do. We're going to use this answer feature. So I'm going to do negative 32, and then I'm going to multiply that by the previous answer. Remember, that's above the negative button. So I'm going to do second, and then the negative button, and there's that answer. So I'm doing that answer squared, and then plus 39, and again, times the answer. So second, negative. Okay, I didn't even need the multiplication. It's going to assume that, but I'm going to go ahead and throw it in because it looks weird. Okay, and that's what I'm going to end up with. It's going to be a more precise answer. Okay, so when I plug that in, I came out with a vertex of 0.609, comma 11.883. So how high does the dolphin end up going? He goes 11.883 feet. There we go. All right, why is there no constant at the end of this equation? Take a second, think about that. Constant. A constant at the end of the equation would be a number added at the end, so like plus 5 or something. We don't have anything there, and this is standard form. So again, think to yourself for a second, what did the constant at the end of the equation do when you're looking at a graph in standard form? That was your y-intercept, right? So what this is telling me is that my y-intercept is 0. Okay, well, why does that make sense in this situation? It's a dolphin, right? And our y value, our y-intercept, y is how many feet you are out of the water. If it's a dolphin jumping out of the water, he's going to start at 0, right? Yeah, that makes sense. So that's why there's going to be no constant on this particular equation, because his starting height is 0. He's starting in the water. All right, great. So there's that question. I'm not going to write that down. If you need to, you can always replay the video. Think about it a little bit longer. All right, last question. How long does it take the dolphin to land? Remember, we're looking at time here instead of distance. So even though my graph for this guy is still going to look a lot like the other ones, right? Here on this graph, this was distance. On this graph, it's time, right? And if you think about that, that makes sense, right? You can sort of visually see this thing going up and down. But if you think about it, as time goes on, what happens to your object? Well, as the seconds tick away, it goes up into the air, reaches a max height, and then comes back down, right? So the same shaped graph works for either time or distance. Just kind of neat. All right, so how long does it take the dolphin to land? So I want to know here how long. That's an x coordinate, because my x coordinate's time, right? So how long does it take for it to land? I want to know the x coordinate of that point right there. Okay, well, let's take a look. So I'm going to graph this thing, because I don't know how to find the x-intercept on that just yet. That's a lie. I do know how to do it, but you probably don't yet. Okay, so here's my graph. All right, when I take a look at this thing, all right, when I look at my just normal window, I'm thinking, all right, I want the x minimum and maximum. Sure, negative 5 and 50. I don't really know. I'm not really sure what to guess for how this is going to be. So I'm just going to try some numbers and see what happens. And then for the height, 20 feet, that seems excessive for a dolphin, but sure. Let's take a look at it and see if we can narrow it down. Oh, look, there's a little squishy graph over here. So what is this telling me? I'm going way too far out. And yeah, now that I think about it, dolphin's not going to jump 50 feet across. So let's cut that back to say, 15. See if that works better. Okay, not bad, but that's still pretty far off. Look at all this dead space we have. So I'm going to cut it back even more. Let's try going from like negative 5 to 5. Is that going to get me a better graph? That's a lot better, right? I could trim it down a little bit more on either side just to make it so that I can see. So let's go from like negative 2 to, I don't know, 3. Yeah, it's not bad, right? There's my graph. Okay, so I want to find this guy right here. So I'm going to do my intersection. I'm sorry, not my intersection, my 0. Okay. Left side of the graph, there's good enough. Right side of the intercept. And there's my guess. All right, so that is the point. 1.220. So how long? It takes about 1.22 seconds for it to land. Okay, so that's how you're going to use this. So again, always start by asking yourself, what exactly are you looking for and what part of the parabola does that correspond to? Okay, it seems really obvious, but that's the number one spot that I find people mess up. Okay, if you need to, graph it on your calculator. If you don't need to, don't, right? We didn't need to find the vertex in either of these equations. So save yourself the time. Don't bother graphing it. Okay, so that's solving word problems with and without a calculator.